We're going to go over the bell ringer first today, where you were told to solve the quadratic equations that you were given. So anytime that we're solving quadratics, we want to get it equal to 0. That means I need to move that negative 12 by adding 12 to both sides, giving me 6x squared minus 44x plus 14 equals 0. Now I need to check for a GCF. Looking for a GCF, I know that 6 doesn't divide into 44 evenly. The next highest multiple of 6 would be 3. It also doesn't divide evenly into 44s, but if I look at all three numbers, they're all even, so I knew at least I could factor out a 2. So I'm going to go ahead and divide all of those by 2. Then I'm good to make my x now and do a times c above, b below. A times c would be 21. My b is negative 22. I need multiples of 21 that add to 22. Should be pretty easy to stop at the first one because 1 plus 21 is 22. But this time, they both need to be negative. Negative 1 times negative 21 is positive 21. Negative 1 minus 21 is negative 22. Then we take our side numbers and divide it by 3, because that is our a. Negative 1 over 3 does not reduce, so we're just going to keep that as negative 1 over 3. And I would have negative 21 divided by 3, which we know reduces to negative 7. At this point, you should be able to use the shortcut of just switching your signs once you have reduced those fractions. So one of my x's I know is going to equal 1/3. The other x is going to equal positive 7. Proving it with the zero product property, we would know that this factor would become 3x minus 1. This factor would be x minus 7 equals 0. Set both of the factors equal to 0. This one's pretty simple, or the second one's simple on my paper because all I had to do was add 7, so I went ahead and did that. On this one, I would have to add 1, divide by 3, and x equals 1/3. Let me make sure that looks like a 3. So like we said, x equals 1/3, and x equals 7. Now let's look at b. We needed to get it equal to 0 as well, so let's go ahead and add 10x. That term would go in the middle because it's an x term. So we'd have x squared plus 10x plus 25 equals 0. Now some of you guys might be able to see the shortcut you are able to take because you notice that 25 is a perfect square. The square root of 25 is 5, and if I double 5 for the middle term, it's 10. So I know this is one of our special cases. But if you didn't see that, it's okay because you could still do the x and have a times c, which is 25. Your b is 10. You need multiples of 25 that add to 10, which I was already talking about the square root. So we should have been able to see that it would be 5 and 5. The side numbers would be 5s. Now, if I look and I divide by my a, it is 1, so it's not going to change these side numbers. So I already know that my factors are x plus 5 and x plus 5. Or that special case of x plus 5 to the second equals 0. So I'm only going to need to solve it for one of my x's because they're the exact same x. It'd be x equals negative 5. So for today's lesson, we are going to continue using Desmos, but this time we are going to be solving systems of equations and inequalities, and just working with Desmos to be able to see the graphs, read them, and make sure that we are comfortable with Desmos so that we can start solving quadratics like what we solved today on paper on Desmos. All right, so let's do some review with systems of equations. On this problem, it says a hotel has 260 rooms. Some are singles and some are doubles. The singles cost $35 and the doubles cost $60. Because of Comic-Con convention, all of the hotel rooms are occupied. The sales for this night are $14,000. How many of each type of room does the hotel have? All right, so the first thing we need to do is identify what our X and Y are going to equal. So those are the two things I need to find out. It says how many of each type of room does the hotel have? Well, how many types of rooms do I have? There are singles and doubles. So let's go ahead and let X equal the number of single rooms and Y equal the number of double rooms. The next thing we look for are totals if we can. So if we look, we have a total of 260 rooms and a total of $14,000. So let's go ahead and set two equations equal to that. Then what do we know about these two totals? So 260 makes up the two types of rooms. Well, we have already designated that the number of single rooms would be X and the number of double rooms would be Y. So if I added both the single rooms and the double rooms together, it'd be 260. So that should be X plus Y. And then for the $14,000, we would need the dollars amount. So $35 per X, or $35 times the number of single rooms, and $60 times the number of double rooms. So those equations would be X plus Y and 35X plus 60Y. So let's go ahead and type this into Desmos. All right, so we should graph both of these. I cannot see the graph or the point of intersection, so I'm just grabbing the graph and dragging it. You can always use the plus or minus over here to help zoom in and zoom out. Click on the point of intersection, and this would be our solution. We got the answer of 64 and 196 because that's where the two lines intersected. So now we just need to make sure that we know what this answer tells us. This answer tells us that there are 64 single rooms and 196 double rooms. So we could say there are 64 single rooms and 196 double rooms. Go ahead and try to work through the other examples, pause the video, and then come back to this if you get stuck or need a couple hints to go on. This one was extremely similar to the last one we did. It said tickets for the homecoming dance cost $15 for a single ticket and $20 for a couple. Ticket sales totaled $2,280 and 128 people attended. How many tickets of each type were sold? As we know, we want to label what our X equals and what our Y equals. This one, we're going to let the number of single tickets equal X and couple tickets equal Y. The two totals we should have found were 128 and 2,280. What makes the 128? What's the type of ticket? So that'd be X plus Y. And the $2,280 came from $15 per X plus $20 per Y. Should have typed that into Desmos. My graph is still from the other graph, so it's too high. So I'm gonna have to drag and drop below. You can zoom in anytime you want to click on it. And our intersection for this one is 5672. We found the intersection of 5672. And this tells us that there were 56 single tickets and 72 couple tickets sold. Some students went to order shirts with their school logo. One company charges $9.65 per shirt plus a setup fee of $43. Another company charges $8.40 per shirt plus $58 fee. For what number of shirts would the cost be the same? So for this one, it's a little bit different. Maybe you guys could have recognized that since it says the price per shirt, that would be a number X plus the setup fee or starting point. So this was going to be in Y equals MX plus B. Our X, we're going to equal the number of shirts because that's what we're multiplying per shirt, the price per shirt. And then let's go ahead and let Y equal our total cost of that order. Okay, so we know Y equals, like we said, the total cost is going to change for each company. So for the first company, it's $9.65 per shirt plus the 43, pretty easy to write. And then the second one would be $8.40 X plus $58 starting fee. Graphing this into Desmos. Once you have it typed in, it automatically graphs it for you. Oh, this one crosses way up here. And this one is kind of somewhere in between here. Oh, see, just click anywhere and it will pop it up for you. So here is our intersection. We got the intersection of 12 and 158 and 8/10. This tells me that each company charges the same amount at 12 t-shirts, and that price for the 12 t-shirts at both companies would be $158.80. Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. Which system of equations could be used to determine the cost of 1 piece of fudge, F, and 1 piece of bubble gum, G? I'm still going to use X and Y. Feel free to use F for fudge and G for bubble gum. Either way, it doesn't matter what you use for your variables as long as you designate what each variable stands for at the very beginning. So my X is going to be the cost for fudge, and my Y is going to be the cost for bubble gum. The two totals we saw were $5.70 and $3.60. Chase bought 5 pieces of fudge, so 5x plus 3y. Sarah had 2 pieces of fudge plus 10 pieces of bubblegum, so that would be 2x plus 10y. Graphing this into Desmos. And we would definitely need to go out on this one. Let's go ahead and zoom out so I can go back in and click. There's our intersection. This intersection tells us the cost of each item, so we should sum it up by saying that for each piece of fudge, it costs $1.05, and for each piece of bubblegum, it costs 15 cents. Last one, we're going to do a system of inequalities just to get some good practice and review in. So on this one, it says you need at least 3 pounds of fruit to make muffins. Blueberries cost $4 per pound, strawberries cost $3 per pound, and you can spend at most $21 on fruit. So the reason why I know this is automatically going to be inequalities is because of the words at least and at most. They could use greater than, less than, no more than, and those would automatically be indicators that they are going to be inequalities because you have a limit on the different numbers. We still need to label our x equals and y equals, so we're going to let x equal the number of pounds of blueberries and y equal the number of strawberries in pounds. The first information that I knew was said at least 3 pounds. So if I want at least 3 pounds, that means I want 3 or more. So I know that my first inequality is going to be greater than or equal to 3 because this is going to be my fruit. The next one said at most 21. If I can spend at most 21, that means the max I can spend is 21 or anything less than that. So we're going to say less than or equal to 21. Finishing the inequalities, 3 is the number of fruits. And to make up their fruits, we have blueberries and strawberries. So that should be x plus y. And the $21 would be 4x plus 3y because that's the cost of each of those fruits. Then we are going to graph this into Desmos. Okay, for typing in inequalities, this one is going to be a little different because we need to type the inequality. And to be able to click the inequality, you're going to have to hit this keyboard at the bottom. And it's going to pop it up, and here's your inequalities. So we knew x plus y is going to be greater than or equal to 3. And it automatically shades for you. You don't even have to check any of it. And then 4x plus 3y is less than or equal to 21. So anywhere in this shaded region would be a true statement. Now, can we have negative fruit? No, so it would cut off right here and also up here where my strawberries would be at 0. So any of these points in this section would be a solution. So by looking at your guys' graphs, you should be able to see it says use the graph to determine whether you could buy 4 pounds of blueberries and 1 pound of strawberries. So they wanted us to check to see if we get 4 pounds of blueberries, so 4 pounds of blueberries, and go up to 1 pound of strawberries, and it's in the shaded region, so I'm good to go. So when we check, it was. The other one they wanted me to check to see is if we could get 2 pounds of blueberry and 5 pounds of strawberries. This is outside of the shaded region. This is not true. So we could not buy that with those stipulations on it. So there are 2 practices for you guys. There's a system of equations practice and system of inequalities. Use Desmos to help you guys answer these questions. And then I challenge you guys to get 4 green dots in a row, but use hints and or the walkthrough to help you with the problems if you need it. Don't forget that if one of the inequalities was not equal to, and the point that they ask for you to check, for instance, if it was 2, 1, and it lands on the dotted line, it is not a true statement because it is not equal to that value. So get some of that practice in, and I hope you guys have a great day.